last time we met, we looked at graphing our sine function, right? Y equals sine x, okay? And remember, we started by just looking back at our linear equation. How did we graph when we didn't know how to do anything? We plotted points, right? And then we looked at some tricks to graphing the sine function. So, for instance, there it is. If you had the equation y equals 2 sine 4 theta. So now instead of plotting points, so to speak, right, we look at this and we know that the amplitude is 2. And we know that the period is, right, to find the period, we do 2 pi divided by 4. So the period is pi over 2. Okay. So our shortcut now is, that means it's going to start and end at pi over 2. Halfway between that, right, if we look at our unit circle, right, we start and we end here, but halfway between that, sine is also equal to 0. So halfway between this, it's going to be equal to 0. Okay? And then, right, looking at your unit circle again, halfway between these two zeros, it's equal to 1. So halfway between these two zeros, it's not 1 in this case, it's going to be 2, because we've got that 2 in front, that amplitude, right? Halfway between these two zeros, we're down at negative 1. So now we go down there. So that's our shortcut to graphing these. We know our amplitude, we know our period. We can get a quick sketch of the sine curve because we know the shape of that sine curve, okay? And then we can continue this. If it has a period of pi over 2, then that means we're going to see this same curve 4 times between 0 and 2 pi. So we're going to do it again. Okay. So make sure that you pay attention to what interval you're being asked to graph. I told you when you did your homework, you only had to worry about one period, and that's fine. But if you were asked to graph this curve over the interval from 0 to 2 pi, you'd have to do it like this. So we should be seeing this happen 4 times because its period is pi over 2. Okay? Now, did we go over how to graph it on your calculator?
Yes.
We did. Okay. So you can always double check it. I'll just put this in here very quickly to show you again. Okay, I did this is in radians, so I'm going to change this back to radians. I think that's the right one. Okay, so my window, I'm going to go from 0 to 2 pi. And again, when you press enter, it's going to change that. Okay, so looking at my graph here, each interval, each mark represented pi over 4. So I'm going to try to match my graph. So I'm going to do pi over 4 here. And we're going to go from, that's good, -3 to 3. So when I graph that, sure enough, that's what my graph looked like. Okay? Questions on that? Okay. Let's look at cosine. Remember, cosine is the x coordinate. Actually, let me pull up those videos again. Let's see here. Oops. It'd be better if I actually looked in pre-calculus instead of algebra 2. Okay. So I'm going to look at the guy with the cool British accent. Maybe. Wow, it's very slow. Okay. There it is. Okay, so we saw this part the other day, right? So we're going to, come on, get out of the way. There we go. Okay. So we saw all this where he was talking about the vertical motion. Okay. Right. So you see as the ball's moving, right? So right now, the blue ball is here. So this yellow ball, this is my vertical movement, and the yellow ball is in line with it. And here's my horizontal movement. So this yellow ball is in line with the blue ball, right? So this is the horizontal movement. Okay. So if we're looking at that circular motion, the cosine wave is giving us the x component of that circular motion, okay, which we know from our unit circle, okay? So let's go back and let's look at graphing just a basic cosine function, and then we'll do some more complicated ones. I can get this all clear here again. Okay, so we're just going to look at y equals cosine x, okay? So graphing it on it still has the same period. It still has a period of 2 pi. It's going to take 2 pi units to complete its cycle, right? So what is the cosine of 0? What's the no, sine of 0 is 0. So cosine of 0 is 1, right? Cosine of 0 is 1. Okay? So it's similar to the sine function in that I'm going to start and end at the same spot, right? It has a period of 2 pi. So that means it's going to take 2 pi to finish a full cycle. It's going to start and end. Now, your sine curve started and ended at 2 pi. Your cosine curve is going to start and end at 1. Okay? Now, look at your unit circle. Okay, so we go all the way around. We're starting here, and we go all the way around, and we're ending here. And the coordinate here is 1, 0. So it starts and ends at 1. Halfway, what happens halfway? What is that x value? Negative 1. So halfway would be pi. Pi is going to be at negative 1. Okay? Now we're using the same process that we did with the sine curve. Halfway between these two spots, between 0 and pi, is pi over 2. Now what's happening with the cosine curve at pi over 2? What does it equal? 0. Halfway between pi and 2 pi, we're at 3 pi over 2. What's the cosine at that point? 0. So my cosine curve looks like this. Okay? And what's actually happening, I know it has that shape, and I'll show you why I know it has that shape. Okay? Let me just sketch in my sine curve again. Here's my sine curve. Okay? Now, let me just show you. I went one full time around the circle. Okay? Now, what if I went the other direction? So I want to figure out what's happening here at negative pi over 2. If I go negative pi over 2, what's the cosine at that point? What is it? It's 0. Cosine of negative pi over 2, right here, is 0. So look at that curve. What do you notice? Look at that curve here. Doesn't that look like a sine curve? The cosine curve is the same as the sine curve, but it is shifted over pi over 2 units. So that's why I knew that the shape of this cosine curve here had that same wave to it, that same curve as the sine curve had. Because it is the sine curve, but it is shifted over pi over 2 units. Okay? So the way I recognize a cosine curve, if they're basically the same curve but shifted, right? Look at the y-axis, right? A sine curve is going to cross the y-axis at 0. The cosine curve is going to cross the y-axis at 1. Okay? So we've got the same shape. If I do this right. Somehow I messed up. Oh, it's got to go further. Sorry. Same shape, but shifted over. Okay? All right. So my cosine curve is going to actually look like this, starting and ending at 1. Halfway in between, it's at negative 1. And then we've got 0 halfway between that. So there's my cosine curve. Okay? So do you want to use the little mini whiteboards? Okay, you guys like the mini whiteboards? Okay. Okay, on your whiteboard, you are sketching y equals 3 cosine x. I find cosines to be harder to do. Yes?
If it starts at 1, would I add 3 so 4?
I don't know. What do you think? Good question. Y equals 3 cosine x. Okay. What's the amplitude? 3. Okay. What's the period? 2 pi. Yeah, the period's 2 pi. Okay, so where are we going to start? 3, because the amplitude is 3. Where are we going to end? 2 pi and 3, right? 2 pi comma 3, we're going to end. What happens halfway in between at pi? Go down the negative 3. Good. Halfway between those 2 points, we have 0 and 0 here. Make sure that you draw that curvy. We don't want it to look like an absolute value, right? Draw it nice and curvy. And there you go. Feel good about that? Okay, let's do another one. Let's do y equals 2 cosine 2 pi. I'm sorry, 2 theta, not 2 pi. I don't know what I just did there. 2 theta. Or 2x, whichever one you want to call it. Cosine 2x, right? Guys, you're getting it. Look at you. Good job. All right, we're getting it. So I see a lot of you are sketching the curve to shape. Make sure you label it, right? Okay, so what's the amplitude of this one? 2. So we're going to start at 2. What's the period? Pi. 2 pi over 2 is pi. So my period is pi. So at pi, I'm going to end at 2. Okay. You're drawing your graph in there. Make sure you have this point of pi over 2 labeled. All right, we're down at -2. I see a lot of you have the shape correct, but you've got to make sure you label your x-axis. Okay. This is pi over 4 here. So we're at 0 at pi over 4. So what's this coordinate right here? 3 pi over 4. Yeah, 3 pi over 4. So we've got a 0 there also. I think probably one of the hardest parts about graphing these is labeling those points. Right? Okay. So let me show you how you figure out what those coordinates are. Yes, Jordan. On the quiz you took today?
Yeah.
No. Okay, so look, how do I figure that out? Yes, sorry, Gavin.
I don't understand how you're figuring out like when each point crosses the axis.
Okay.
It's still not-
Yeah. So we know where beginning and end, right?
Yeah.
Halfway between the beginning and the end, that's my lowest point. Halfway, so this is the x coordinate of my lowest point. I go halfway between the beginning and the lowest point, and that gives me that 0. And then I go halfway between here and here, and that gives me where it's crossing the x-axis.
Okay.
Because it is symmetric. Okay?
I still don't understand like the 2 pi over 2 plus pi. I really don't understand what is pi mean in terms of.
So you don't understand this part here?
No, I still don't understand like what the period really means.
The period means how long is it going to take to finish the cycle. So if I started up here at 2, how long is it going to take me to get back up to that 2 again? Okay? If I continue this graph, it's going to look exactly the same again, like that, right? So that pi takes pi units to do one full cycle. Okay? Yeah. Okay, so how do I figure out these points here? Because that's a challenging part. So I know that I'm down here at pi over 2, right? So in order to find where it's crossing the x-axis, I'm taking half of that. Well, multiply it by 1/2, and there we have pi over 4. That tells me that this coordinate right here is pi over 4. Okay? Now figuring out the next one is a little bit harder. So what I have to do is think of these in terms of with the same denominator. If this is pi over 4, then this point, I'm going to write it as 2 pi over 4 instead of pi over 2. So now I can see the next one here, right? I'm taking another pi over 4 units, so that means this has to be the 3 pi over 4. Okay? That's the easiest way to do it. Figure out how much this is and then use the same denominator. Okay? Okay, let me give you one more to try before we move on to some shifts. Okay, y equals 1/2 cosine 1/2 x. Make sure you label your axis. Okay, so I've got a period of 4 pi, 2 pi divided by 1/2. So, and I've got an amplitude of 1/2. So I started at 1/2 and I end at 1/2. And my end is at 4 pi. Halfway in between, I go down 1/2. So now I'm looking halfway between the 0 and the 2 pi, and that's going to be at pi. So I put my 0 there. Halfway between 2 pi and 4 pi is 3 pi, so I put my 0 there. So now I'm ready to draw my curve. And there we go. How'd you do? Okay. All right. So when we looked at this with the sine function, I showed you the general form of the equation. Okay. So the general form of the equation for the sine function was y equals a sine bx minus c plus d. The a was our amplitude. And we used the b to figure out our period. Okay. It's the same thing for cosine. Y equals a cosine bx minus c plus d. Okay, so I'm going to look at the d and the b to get today with you. And we're going to use the sine function just because sine just tends to be a little easier since it goes through 0, 0. Okay, so let's look at y equals, let's just start simple, sine x plus 1. Okay. Now, if I gave you an equation y equals x squared plus 1, how would that graph relate to the base function y equals x squared? How would that translate? We know y equals x squared, right? That's just a parabola, right? So what would y equals x squared plus 1 look like? Shift up 1. Well, it's the exact same thing. We're going to shift our sine curve up 1. So what I like to do is just sketch out very lightly my basic sine curve, right? Do it at a dotted line, okay? So there's my basic sine curve. And instead of making this real complicated, right, I'm just going to take each one of those points and I'm going to shift it up 1 unit. So we shift up 1, this goes up 1, up 1, up 1, up 1. There's my final sine curve, sine x plus 1. Okay? So when we add a number at the end like that, what it's doing is it's changing my rest position. Okay? So on my basic sine curve, my rest position is the x-axis. So it's kind of like it's shifting the x-axis up. So the x-axis, or the new axis, becomes y equals 1 instead. Okay? Some people like to do that first. So for instance, some people like to graph it, kind of sketching in the axis. So let's say that I had y equals sine x minus 1, right? So some people like to say, okay, well, here's my new rest position or my new axis, and then they plot the points from there. Okay, we start at 0, we go up 1, okay, and we go down 1. Some people like to do it like that. I find that that can get confusing later on. So I like to sketch in my basic y equals sine x and then just move every point. Okay, so I'd like you to sketch y equals, let's do 1/2 sine x plus 2. Okay, y equals 1/2 sine x plus 2. So I sketch my base function in there first. Yep. So that 3 pi over 2 is going to go down to 1 negative pi over.
It's 2 pi
Okay, let's.
Rory?
Yes.
Hi there, can I please have Mika here Ferguson to the band room for a moment?
Okay.
Thank you.
All these talented people. Oh.
I'm not.
Maybe they want you to be in the talent show.
Too bad.
Okay. Okay, so let's sketch out. I'm just going to sketch the function y equals 1/2 sine x. Okay. It has a period of 2 pi, so I put my point, beginning and ending point, 0 and 2 pi. Halfway in between, we're at the 0 again. Now halfway in between it has an amplitude of 1/2. So instead of going up to 1, I'm only going up to 1/2. And then we go down to 1/2. Okay. Then we'll go ahead and we'll sketch our basic curve in there. Okay. Try not to take shortcuts. Those shortcuts are leading some of you to make mistakes, right? Okay, now we're ready to do the plus 2. So each one of these points is going to move up 2. So from 0, I move up to 2. From 1/2, I'm moving up to 2, so that's going to be at 2.5. From 0, we move up to 2. From -1/2, I move up 2, which means it'll be at 1 and 1/2. And then from 0, we move up to 2. So here is my final curve, right? And there's my new rest position. The rest position is at y equals 2. Okay? Need to try another one? Okay. Let's try another one before we do the horizontal shift. Thank you. Okay. Okay, so this one's going to be y equals 2 sine x. Actually, make that 2 sine 2x. 2 sine 2x minus 1. Okay, here we go. So I'm going to draw my base function. So it has a period of pi. Right? So we have a period of pi. That means we're going to start and we're going to end at pi. Thank you. Okay, we're starting and ending at pi. Okay. Now we're going to go halfway in between. That'll be pi over 2. So we're crossing the x-axis there again. Remember, your sine curve is going to cross that x-axis 3 times. Okay? So we're going to cross the x-axis at pi over 2. Now halfway between pi over 2 and 0, so I'm going to take 1/2 of that, we get pi over 4. So this is pi over 4. We're going to go up to our amplitude, which is 2. Okay? And then over here, halfway between pi over 2 and pi, I have 3 pi over 4. So at that spot, I'm going down to -2. Okay, we just keep cutting it in half. Okay? All right, now this is my curve before I do a shift. All right, that's before we do the shift. Now, let's go ahead and do the -1. So I'm going to move every point down 1. Down 1, down 1, down 1, down 1, and down 1. This is my final curve. Okay? Questions? Okay, what time is this period end? We're good. Okay. We're going to make it a little more complicated. We're going to do a horizontal shift. And these actually are kind of confusing. So let's look at sine y equals sine x plus pi over 6 plus 1. Okay, I've got to change my values here. Okay, so first let's figure out our period. What's our period? Come on, you guys notice, what is it? 2 pi, okay? There's my period, 2 pi. Okay, so I'm going to start at 0 and end at 0. Okay. Halfway in between, I'm at 0. Okay, now we've got to deal with that pi over 6. Let's go back to our parabola example. If I had y equals x minus 3 squared, what would that do with my parabola? What would the shift be? 3 to the right. So what do you think this shift will be? Pi over 6 to the left. Okay, so I wanted to figure that out first before I start marking my graph, right? So if this is pi, I've got 3 little marks in between. So I'm going to make this, let me see, pi over 3, 2 pi. Oh, that won't work. Well, that's kind of a pain in the neck. Okay. So this is going to be pi over 4, 2 pi over 4, 3 pi over 4. My graph is bad, so you're drawing your own graphs there. So what I would do, I'm going to go to another blank page because I'm confusing you with this. Let me get a blank page here. Okay. Okay, here's my graph. And we went to 2 pi. And then this is pi. Okay, so I need to go pi over 6. So I'm going to do 1, 2, 3, 4, 5. So this is pi over 6. 2 pi over 6. This is 3 pi over 6, right? So I'm making my graph so that I can do the shift, okay? 1, 2, 3, 4, 5, 6. Okay. All right. So let me see. I had sine x plus pi over 6 plus 1. All right. So let me draw my curve in there. I've got, this is my basic curve before I do any shifting. Okay. Before I do any shifting. There's my basic curve. That's my y equals sine x curve. Okay. I'm going to shift it pi over 6 to the left. So when I draw my axis, I make each mark represent pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 will be pi, right? 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. So I figure out my shift before I make my little tick marks on my graph, because I need to be able to shift it 1 unit to the left, okay? So I've got to go 1 unit to the left. So this is pi over 6 or negative pi over 6. Everything is going to shift over 1 pi over 6 to the left. Okay. So there's the curve, y equals sine x plus pi over 6. Drew my curve in there, my y equals sine x, that's a basic curve. The only thing that's different right now is that I made each mark pi over 6 instead of pi over 4. Okay, so I shifted everything to the left. Now what do I have to do? Shift everything up 1 unit, right? So shift everything up 1 unit. So this will be right here. Everything up 1 unit. So you just have to be careful as you're drawing it in there. Just be very careful with your movements. Okay. And here is my final curve. Okay. Y equals sine x plus pi over 6 plus 1. There's my curve. Okay. I'm going to have you do one of them. Okay, let's do y equals sine x minus pi over 3 plus 2. So I'll give you a hint. Draw the first curve as y equals sine x, just dotted line. And the next one, you're going to do a dotted line, y equals sine x minus pi over 3. And then your last or final curve, you'll do the y equals sine x minus pi over 3 plus 2. Okay, so you're going to do it in those stages. Alex, you're going to run out of room for your vertical shift. Yeah, you got the right idea. It's just you're going to run out of room.
Yeah.
Okay, that minus pi over 3, what's that going to make you do? Shift it which way? To the right. So when you're drawing your graph, don't put that 2 pi on the very right edge because you've got to shift your whole curve over pi over 3 units. You've got to have room to shift it, right? Okay, I know you're not all finished, but let's work on this together, okay? Okay, so I'm going to plot my y equals sine x, 0 and 2 pi, and we're going up 1, all right? So here's halfway. Okay, so here's my basic y equals sine x. Everybody okay with that? Okay, now these marks, this is pi over 2, this is 3 pi over 2, all right? So the next thing I'm going to do is my horizontal shift to the right, and it's moving pi over 3. So I need to make marks here. 1 pi over 3, 2 pi over 3, 3 pi over 3. So this is pi over 3, 2 pi over 3, and then of course this is 3 pi over 3. Okay. 1 pi over 3, 2 pi over 3, 3 pi over 3. Okay, so 3 pi. So this is 4 pi over 3, 5 pi over 3, 6 pi over 3. I didn't worry about the pi over 3 when I was graphing the basic function. I just left that as pi over 2. I don't really care because it's just a sketch, right? So now I'm going to take that basic function. I'm going to move it pi over 3 to the right. Every point moves pi over 3 to the right. No, it's going to be the opposite of whatever's inside the parenthesis. Okay? And here's another pi over 3, so this is 7 pi over 3. Okay, so here's my function shifted pi over 3, right? Y equals sine x minus pi over 3. Now I'm going to go up 2. So we're going to take that same curve and we're going to shift it 2 units up. So I've got this point, I'm going 1, 2, and we go 2 up. I find that if you try to do too much all at once, it gets confusing. 1, 2, and this is going 1, 2. So there's my curve. Yes? You can leave it like that for now. Yeah. Okay. How could we easily figure out where this is going? When it crosses the y-axis, what do we know? X is 0. Right? When it crosses the y-axis, x is 0. So y equals sine of pi over 3 plus 2. Right? The sine of pi over 3 is square root of 3 over 2 plus 2. So you could use your calculator to figure that out. Square root of 3 over 2 plus 2. 2.87. So it's going to cross at approximately 2.87. I guess that makes sense, right? Oh, that doesn't make sense. What'd I do? Oh, it's minus pi over 3. Oh, yikes. Which makes this negative. Plus 2. 1.13. Okay, that makes more sense. So it's crossing the y-axis right about there. So it's doing that. Okay? Okay? All right, we're going to stop there because this was a lot and your brains are hurting you. No homework tonight. Okay? So this is a good time if you're a little lost because we did it fast. This is a good time to ask for some help.